Hey there, we're going to do a little bit of a review some skills that we've just been working on and some skills that we've seen a couple months ago that are going to come back and we're going to use a lot in a little bit. So you need a sheet of paper. Lined paper is good, but if you don't have lined paper, that's okay. For number 1, please write your name. For number 2, this is the problem, and you don't need to write down the problem, but you do need to write down all of your work. And your work is the synthetic substitution machine. Again, this box needs to be 2 rows high. Don't make it too high. I've seen people do that, and then you get this weird space in between, which is probably going to happen to me in this problem. And then sometimes it makes it tough to line things up, which can break the machine. So remember, whatever x is, that becomes your multiplier out in front. Then your coefficients of the polynomial get listed in the first or top row. If there are any terms missing, you need to put 0 in place of that missing term. But I do not see any missing terms here. It goes power of 4, power of 3, power of 2, power of 1, and this essentially is x to the power of 0. All right, so now let's run our machine. To start your machine, you drop down or push the primer on the leading coefficient. You just bring that 5 down. Then you multiply that 5 with your multiplier, whatever x is. You always are going to be multiplying by 2 in this case. So you get 10. Whenever you have 2 numbers on top of each other, and see how there's a lot of space between here? I made that box too big. I should have these things lined up better. In fact, I think I can fix that. Boom, boom, boom. Anyway, when you get 2 numbers in the box on top of each other, you add. So -2 plus 10 is 8. Then you take the number on the bottom, you multiply it by 2, you get 16, add that together. So when you have numbers on top of each other, you add. Now you're in the multiply zone, so you take 23, you multiply it by 2, you get 46. 46 plus -5 is 41. Take 41 times 2, you get, take 41 times 2, you get 82. Now add 82 and 9, you get 91. So when you plug 2 in for x in this big polynomial, and you punch the whole polynomial in your calculator at once with the substitution done, your calculator will say 91. Number 2, very similar, but number 2 is a little trickier. Well, your multiplier is -3, but check for any missing terms. Are there any missing terms? I see degree 4, I see degree 3, I do not see degree 2. So there's a missing x squared term there. It means there's 0 x squareds. So your coefficients are 2, -5, 0 to go in place of that x squared. And lastly, well, not lastly, we're not there yet, but the coefficient of x, or of any term without a number out in front, the coefficient of any term with a missing coefficient is 1. And then last but not least, we have that -3 at the end, that constant. Push down your primer, drop the 2 down. Now to work across, take that 2 and multiply it by -3, gives you -6. Now add. If you're not a fan of adding negative numbers together, use your calculator. -11 times -3 is +33. Add 0 and +33, you get 33. Multiply 33 and -3, you get -99. See how things are not lined up right now? That gets a little dangerous. I'm just going to reshift things a little bit. As long as you can keep things lined up, I've seen people make lines to try to like separate. You know, you need to stay organized on that, so whatever helps you do. Sometimes the lines get confusing though. -98 times -3 is +294. And so now we're in this last column. To get our answer, all we do is add those numbers. You get 291. And that should be our output. When we say x equals -3, we can now say that y would be 291. Or f of -3 equals 291. You can always check that with your calculator too, folks. And sometimes we make little operational mistakes when we do the machine. Even though we're doing the machine correctly, we're humans, and so we make little calculation mistakes. You can always use a calculator on the synthetic substitution. The big thing is, in a week or so, what you're going to discover is that when we divide polynomials, which is super tough, we can use this machine instead, this machine that we're all getting pretty darn good at. And these other numbers that I'm highlighting now in green, these numbers on the bottom, are going to be really important for getting our final answer. In fact, I'm almost done dividing, basically. There's just one tiny little step. That's how easy dividing polynomials could be. Alrighty, from here, folks, we're going to review a little bit of factoring. GCFs, greatest common factors. It can be a number. You look at these terms, and this is for number 4 for your polynomial, for your review. So for number 4, you'd write down number 4, and then for these, you can just write down the answer. So is there a number that we can factor out of all 3 terms? And factor out the biggest one. Yes, we could factor out a 2, we could factor out a 4, but factor out the biggest one, it's an 8. Now, this term doesn't have an x, so I can't factor out an x. Oops, I did something bad there. 8 times 2 is 16. So you can either divide all of these terms by 8 to figure out what goes in the parentheses, or I'd like to, I always thought about multiplication instead. 8 times what gives you 24x squared, 3x squared. 8 times what gives you 16x, 2x. 8 times what gives you 40, 5. So that's one way of doing it. Alrighty. Whoa. Alright, what can we factor out of number 5? So for number 5, you can factor a 10 out of all of these numbers. That's the greatest common factor. But notice, all of these terms have an x, so we can factor out an x. So then I like to think 10x times what is 20x cubed? It'd be 2x squared. And then we get 10x times what's negative 40x squared? It'd be negative 4x. And then last but not least, positive 3. I'm going to let you try number 6 on your own. Try your best, it'll be all right. Factor these completely. So many or all of these on this slide don't have a GCF. But remember, if it's a trinomial, we can look for numbers that multiply to the constant and add to the middle term. So numbers that multiply to 24 and add to 11 be 8 and 3. By the way, if you weren't sure that it was 8 and 3, you could write down just the ways to multiply to 24, because there's not that many. And then instead of thinking about multiplying once you have this list made, then pretend there's a plus sign in between. Boom. That's the magic pair. What you do with that magic pair is you shove it behind the x's in factored form. And now if you were to FOIL this together, so this is your answer, by the way, folks. If you were to FOIL this together, factoring is like dividing. They wanted you to factor or divide apart that polynomial. That's the answer. If you were to you can check factoring or dividing by multiplying. So if you were to FOIL this back together, I'm finally going to say it, FOIL it together, you get the original polynomial. That's how you can check your answer. Number 8. Actually, I'm going to do number 9 instead. Number 9. There's no GCF, but you're looking for a, it's a trinomial. You're looking for numbers that multiply to negative 24 and add to negative 5. So again, you can make your lists, your ways to multiply to 24. That's how you want to start. And then, because we're multiplying to a negative 24, one of the numbers needs to be negative. And it can either be the smaller number or it can be the bigger number. Since I see in this case we're adding to a negative, it would actually have to be a bigger negative number, because that way when you add them together, the negative wins out. So it's going to be 3 and negative 8. Those are the two numbers that multiply to negative 24 and add to negative 5. So those numbers go behind the x's in the parentheses. So there's your factored form. I have factored it. Lastly, numbers that multiply to 24 and add to negative 11. Now, here in red and blue in this box are the ways to multiply to negative 24. Let's change it back to multiplying to positive 24. So either both numbers have to be positive, but that's not going to work because any way I would add these positive pairs of numbers together would give me a positive. So what we're going to do is actually make both sets of numbers negative, because a negative times a negative gives you a positive 24, and now when you add the right pair together, you'll get a negative 11 specifically. So it's x and a negative 3 and an x and a negative 8. There's your factored form. Last but not least, factoring when a is greater than 1. Now, if this had a GCF and I could factor the 2 out, that would be fantastic. But I can't factor that 2 out because 2 is not a greatest common factor of all of the terms. So when you do this, you need to multiply your a term, which is 2, times your c term, which is 15. You're actually looking for ways to multiply to 30 and still ways to add to 13. So you get 3 and 10. I'm going to do this method. I'm going to factor this one using the slide and divide method. I'll do number 12 using the split the middle method. You hopefully will recall which method you preferred. All right, so when you do this, the slide and divide method, those of you who are split the middlers, this would be a no-no. What you do is you just shove these numbers from the diamond straight behind the x's. But that's not right, folks. Don't erase anything. It's not right because if you were to FOIL this together, you totally wouldn't get the original polynomial up on top, so it's not right. But we slide and divide. This 2 right here, this leading coefficient, gets slid underneath those numbers and we divide. And in my second parentheses, it says x plus 10 divided by 2. Well, that's just the same as x plus 5. So that factor is correct. Always try to simplify these fractions, this dividing if you can. Like I did, 10 divided by 2 is 5. Sometimes you can reduce the fraction and you're still left with a fraction. If you can reduce it, you have to reduce it. After that, if you're still left with a number on the bottom, that number has to go out in front of the x. So that 2 slides out here. And check that out, folks. If you FOIL this, you get the original polynomial. This is the correct factored form. I just did slide and divide. Go ahead and try that on number 12. In fact, if you know that's your method, please, again, do it for number 12. Check it, see if it's right. If it's not right, I'll give you some feedback. That's probably the best way to learn. Those of you that are like, what did Mr. P just do? That's not the way I taught it. You're right. It's not the way I taught it. It's the way I did it on some videos. Split the middle method. So here, you're going to still start it out the same way. There is no GCF. I'm stuck with that 3 out in front, so you multiply it with the constant at the end. 3 times 21 is 63. And then you're going to look for numbers that add to 16. And 9 and 7 are the pair that do that. But here's the difference. We now, instead of, well, let's just not even talk about what I just did for number 11. We're going to split the middle. So instead of writing 16x, I'm going to write 9x and 7x. Or I'm going to write 7x and 9x. And you bring down the start and the end. So folks, this method's, I like it because what I just wrote in red, you get that it's equivalent to what's in black. It's totally equivalent. The key is just picking out the right middle numbers by doing this diamond. Now, there's lots of ways to get 16x. I could have done 10x and 6x, but it's only 9 and 7 that will allow us to proceed with this factor by grouping, which will allow us to actually factor this thing completely. So when you have 4 terms, the way it's written now in red, you group the first 2 and group the last 2, and then you factor out what you can out of, you factor out what you can out of the first pair. You can factor a 3x out of the first pair, so you're left with x plus 3. And then you factor what you can out of the second pair. The second pair says 7x plus 21. You can factor a 7 out of that. And then I'm left with an x plus 3 there. Huh. My two parentheses match up exactly. They should. If they don't, make sure you're doing the process correctly. Either your diamond wasn't right or you didn't take out the greatest common factor. Then you take your mini GCFs, the things I just underlined in blue, and you put them together and you multiply them by the x plus 3. Essentially, you're just doing one more factoring step there. You're factoring the 3x and the 7 out of the common factor there of x plus 3. If you FOIL this together, you get exactly what you started with on top. So you know your factoring is correct.